So very quickly, v of t is d by dt of x of t, and you'll have to go back and maybe review how your calculus hits sines and cosines and stuff, but let me cut to the chase. So d by dt of x of t, what it's going to do is be 2 meters times the cosine of omega t, where the omega comes out in front, right? So this is how the derivative is going to go. And if this is at all weird, go and review. So I have to be really careful. Do you remember how omega is 2 pi radians per second? So you know that 2 pi is roughly about 6.28, because pi is 3.14 and 2 times 3.14 is 6.28, right? So the way that you understand how omega is going to multiply the 2m, omega is an angle per time. But when it comes out, because you did some calculus, the magic of the radian, the reason why radians are so important, is because that's the type of angle that works really well in calculus. So let me show you what I mean. So this 2 pi radians per second comes out, and so omega is sitting here. It's 2 pi per second, right? There's the second and the 2 pi. There is the 2 meters. And if you ask what happened to the radians, I'm going to tell you that what you do is when you take the derivative and it comes out of where it needs to be an angle, you just drop the radians, but the 2 pi comes out. This is 2 pi per second times 2 meters times the cosine of omega t, where omega is still 2 pi radians per second. But on the outside, where it's not an angle, this is, it's multiplying the 2 meters. There is no radians. You have to drop the radians. It's not like radians cancels. You just drop it. So at this point, this is 4 times the number pi per second. And actually, let me not put the second below. It's 4 times the number pi times the meter per second. So that's it's a little bit bigger than 12 meters per second is what sits out in front of the cosine of omega t, like this. All right, so just continuing, the acceleration as a function of time, it's d by dt of v of t, so I'm just going to go straight to the derivative. It's d by dt of this thing. It looks like 4 pi meters per second times the cosine of omega t. Same as before, when the omega comes out, you drop the radians, but you have to keep the 2 pi per second. So, so the way this is going to go is when you take the derivative of cosine, it turns into a sine function, but with a minus sign. So this is going to be minus omega times 4 pi meters per second times the sine of omega t, like this, with a minus sign. So I'm going to put in what omega is. Omega is 2 pi per second. On the outside, you drop the radians. So another 2 pi becomes minus 8 pi squared meters per second, but the omega had another second, so it's meters per second squared. So meters per second squared times pi squared is roughly 9, right? 3 times 3, a little bit bigger than 9. 9 times 8 is about 72. So this is like negative 75 meters per second squared, multiplying the sine of omega t. So I just calculated an acceleration. It's got acceleration units out front, and then there is the wiggle that it multiplies on. Okay, so So I'd like you to notice that quickly, x of t is a sine wave, v of t is a cosine wave with a different prefactor, a of t is a sine wave that has a minus sign and a different factor. So I've gone ahead and drawn a sine wave. Can you see the sine wave is the wave that starts at 0 and goes up? So that's the sine wave. Followed by a cosine wave. A cosine wave starts at 1 and goes down to -1. And this is the upside down of that. So this is a negative sine wave compared to that sine wave. So this is a negative sine. It starts at 0 and goes down to -1 first. All right. If I compare to what I have over here, can you see that this x of t goes up to 2 meters and then down to -2 meters, then up to 2 meters and -2 meters, right? And it takes a certain amount of time to do that. Because omega is 2 pi radians per second, 2 pi radians is the same thing as 360 degrees. And this happens every second. That is, it takes 1 second for the angle to go from 0 to 360. So that means that x of t is going to take 1 second to start at 0 and go back to 0 1 cycle later. So this right here is 1 second, and this is 0 seconds. Okay, so over here, I see that v of t has a prefactor. This amplitude is 4 pi meters per second. So I'm going to go and put 4 pi meters per second there, and also -4 pi meters per second here. And our v of t function maxes out at +4 pi meters per second and minimizes at -4 pi meters per second. Our acceleration function has a prefactor or amplitude of 8 pi squared meters per second squared. So it's going in between -8 pi squared meters per second squared and up to +8 pi meters per second squared, 8 pi squared meters per second squared on the positive side. All right, so the reason, so now this I've translated into pictures. So let's just study the pictures for a second. The velocity is the slope of the position. V is slope of x. So v is the slope of that function x. A is slope of v, right? So a is the slope of the velocity. So let's check this. Let's check, is v the slope of x? So check this out. An interesting place to ask first, actually, is if you notice that x of t is horizontal here, right? Horizontal is slope of 0. And if I go down to that very same time, the velocity has value 0. So that, can you see that that actually just filled it out? So the velocity is 0 is the slope of x, and the slope of x is the slope of that tangent line, that red line. Can you see here the slope is negative, and it's as big, sort of large magnitude, but negative as it's going to be, because it's like, you know, in between there, it's like less slopey. So it becomes more and more slopey, and then less and less slopey, and then more and more slopey, and then less and less slopey. So right here, it's the maximum negative slope. And if I go down here, it's the maximum negative value. Before that, this is the maximum positive slope. coincides with the maximum positive value of v of t. This is an important mapping. How do you map or understand the conceptual relationships between x and v? It's thinking this way. This is the map. This is how you understand the relationship. This map relationship happens here as well. Whenever the velocity has a maximum negative slope, that maximum negative slope coincides when a of t is its maximum negative value. And when v of t has a slope of 0, that is v of t is flat, that's when a of t has value 0. So the map is the same. That's important. Thanks for listening.